Hello and welcome again to another episode. Today we're going to be looking at how to repair one of these bad boys. I've got here a 6S 3300 milliamp hour lithium polymer battery and it needs some repair. Maybe you have one of these, maybe you have a smaller one, maybe a bigger one, and maybe you've ripped off one of the power leads, or maybe you've got a big slice through it, need it repaired properly. Maybe you have a balance connector that's ripped some of the wires right off of it. Maybe your racing drone has chopped through it. I mean, whatever the case may be, I'm going to show you how to repair one of these properly. Maybe some of you guys are scared or worried out there about repairing one of these Lipo batteries because they're so energy dense. I just want to show you, I'm going to show you the proper way to do this, so that oftentimes by doing this, this thing's actually safer than it was out of the factory, just with some of the care we're going to take in the connection area here. So join with me here and I'm going to show you how to get started. All right, before we get started, I'm going to show you what tools and supplies you're going to need. First of all, you need some sort of insulator for the leads. You're going to need either electrical tape or some brush-on electrical tape. This stuff is actually really awesome if you've never used it. Pick some of this stuff up, it's only a few bucks. You're going to need some tape. I'm using some fiberglass reinforced tape here. This is really high quality stuff, but even packing tape or anything like that will do. You'll need some heat shrink. I'm using 5mm heat shrink for 12 gauge wire, what I'm going to be using. So I've already cut a couple of pieces there of 1.25 inch. You're going to need whatever connector you're going to be using. I have switched to XT60 pluses. These things are awesome. These are just from Hobby King, and they have the little end that you clip on there, so you have a bigger surface area to pull on, so you're not tugging on the wires all the time. I've already cut here, just to save time, some 12 gauge leads, so positive and negative obviously. Here this is a 6S balance tap because this is a 6S Lipo battery. I just buy these from Hobby King. You can get a pack of 10 of them, I believe it is, for a few bucks. And I just snip it off at 4 inches, and that works perfectly. You're going to need a wire stripper, you're going to need a knife, and then you're going to need your soldering supplies. So for soldering, I have my soldering iron. I'm using a Hakko station here, as you can see. You can wet your pad. You need some good quality solder. This is 6040, I believe. 18 gauge, doesn't even say on it. And anyways, leaded solder, that's all you need. You need some good leaded solder. It flows a lot better than the non-leaded stuff. And you need some flux if you're going to do a good job, and I highly suggest you use that on this project. All right, and the last thing you're going to need too is some heat shrink. I've got some big beefy battery heat shrink here and some scissors to cut it. And I've got my heat gun there for shrinking it. All right, so let's get started. Okay, I've got my 6S 3300 here. I've already taken the covering off. You can just peel it off. Just start it with a knife or whatever. And yeah, once the heat shrink is off, let's take the main protector off here. Sometimes it's a little bit hard to get off. And this is all insulating tape that you'll see here. So you can use your knife and just slit it. And it's okay, just don't short anything out when you're doing that, and it'll be all right. And inside, as you can see, we've got all our connections. So guys, I'm gonna go as fast as I can. Fast as I can doing a good job of this. But it's going to be a little bit of a long video, so if you've done some of this before, you can fast forward certain parts or whatever, but hopefully you can watch through. I'll try and make it fairly quick for you guys. So, got the insulator off. We'll just set that aside. What I suggest is that you take a picture of this, because just in case you forget or you haven't done this before, you might not realize how all of these balance taps go back on. So it's actually pretty easy if you look at this. You've got your main two leads, positive and negative. We're going to check those after to make sure we get them right when we put it back together. And in here, you're basically just starting from left to right, from negative to positive, and it just touches on all of the cells. And so it's not too hard to hook up. It's fairly easy. We've got our positive and negative on the end, which is why there's one extra wire. Anyway, so let's get this thing apart. So first thing we're going to do, turn on your soldering station. I like to use a lot of heat on a project like this because we want to not ruin these cells with too much heat. So I recommend, I'm using 800 degrees Fahrenheit, anywhere from about 700 up to even 850 I would recommend. 700 is a little low, I find, but you want lots of heat, and we'll get on there and off there as fast as we can. So what you want to do now is, you don't have to do this part, but I usually take the flux and just wet each pad a little bit, as you'll see here. And what flux does is it transfers the heat very well and allows the solder to really do its job. So always clean off your tip. First thing, I'm at 800 degrees. I've got my clean tip. I'm going to tell you guys right off the bat, flux, a clean tip, good solder, and lots of heat is the key to good soldering. You get all those, and anybody can solder. It's not hard, but those are the key things that you need. Anytime you have a clean tip, you just take a little bit of solder on there like that, and then I'm going to take this positive lead off here first. So solder transfers heat. So you need to make sure that you've got lots of solder that's transferring the heat down, and that flux is really going to help do its job. So I'm using the biggest tip I have. Generally, I'd like to use one size bigger tip than this, but you can see how much heat it takes, right, to get this. This is 8-gauge wire I'm taking off of here, by the way, so it takes a little bit. So we just get it hot. You can see it pooling there, and I'm tugging on it a little bit, and there it goes. Okay, well, the stuff is still puddled there. I'm going to take this guy off. And, oh, good. I actually got the solder off. I try to usually get that off at the same time, but hey, I'm going to do the negative lead here just so that we can get this out of the way. So I'll just wipe the tip off here. A clean tip all the time really helps for heat transfer, and it does a much, much better job. Get this hot. These have 8-gauge leads on here. Because these are older packs that I have, I'm actually making this for a battery bank for a charging station for my racing quads. So I don't need 8-gauge wire. I'm going to put 12-gauge on here. 8-gauge is just massive. I used to use it for some of my applications, but 8-gauge is very big wire. You can usually get away with 10-gauge if you ever need something that hefty. Just depends on the application. There we go. Take the negative wire off, or negative balance tap off. And so guys, you're never going to short anything when you're on each, pad, obviously. It's when you cross pads what you don't want to do. So, if you do happen to short it out by accident, no worries, it happens. Try not to, because it can do some damage to the lithium inside the battery, and it can cause the IR reading to go up a little bit. But if it's just a real quick short, it's usually fine. We just use heat to get all of these guys off. And our last one. Okay. So now that it's all off, it's not even hardly warm here. So that's the key. Lots of heat and short time on there. You can take out all of these if you want, but it doesn't really matter. They just are in the way for right now. We'll put them in after. That's just silicone, just so that you don't, if you were to crash this battery, so that two terminals didn't touch and short, cause a short circuit or a fire, or cause the Lipo to go up. Okay, what I do next here, guys, is I usually go around. I know I put a little bit on there, but I would try to get these pads nice and liquefied, and watch what happens here. I just give it a flick and flick off all the old stuff. The only reason I'm doing this, guys, is because from the factory they use they use the cheapest solder they can get. I'm not saying everybody does, but in some of these more lower end hobby grade stuff, sometimes they do. And so I like to just get all of the stock solder off before I do anything, just because it makes a much better product at the end of it. So just try not to flick it on yourself. Generally I do this over the floor, so this is kind of awkward doing it up here, but I wanted to do it for the camera. Okay, good to go. So now I'll just move all these bits of solder. Making a mess here. Okay, so next thing. Let's see here. The next thing I'm gonna do is I'm gonna prepare all the pads while we're working on this. So what we're gonna do here is take your flux, very important, and just flux each one a little bit all along. I just put flux in this dropper bottle. It works really well. A lot of the professionals do this that are doing a lot of soldering. So I picked that up from them. It works really well when you need to use flux on hand all the time. Okay, so let's get at it. Again, leaded solder. Make sure you have a clean tip. And then apply your solder. Or solder, as most Europeans say. And I know that's the correct way, but us here in North America don't always follow the proper pronunciations. Okay. So this one right here, this is our positive lead. So I'm going to get this really loaded up here because that's a fairly big wire that's going to go on there. And because these are each individual cells, you guys can just load them up. You don't have to wait for cooling in between. Put lots of solder on there. Makes the job much easier. And this is your negative, so try to get lots on there. Okay, and then let that cool. And while we're letting that cool, let's prepare our balance tap. So I like 4 inches here. We need this end, obviously. So I'm just going to measure out 4 inches. I find I prefer to cut this with my wire stripper because it works so well. So I just map it out at 4 inches. And then I just use this to cut all of them. Like that. And then okay, so I'll, just to save some time here, what you do for lead length here, because I want to run the balance tap out the bottom. So basically what I want to do is every other cell I want to basically have a shorter lead on for those bottom 3. So our positive is up here, okay? And then so this one needs to be shortened, and then this one long. And then this one shortened, this one long, this one shortened, and our negative long. So you can see I've got every other one here. Take these and strip them. I already know that this is 22 gauge. And make it reasonably long, guys, like 1/4 inch. Because, you know, those balance taps get tugged on. And so this is one of those things where I say, you know, you can make this battery pretty safe by doing a few little things, you know, something like this even helps. Oh, guys, I'm sorry, what am I doing here? These are the ones that are supposed to be shortened. These are the ones that are supposed to be stripped. Let's strip these right now. I get talking and not thinking. It's hard to make a long video like this. Usually it's just really short stuff. Gotta actually think a little bit sometimes. Okay, those ones are done. Then what I do for lead length for the shorter ones is if you just measure on the pack here, you can see like I want the base of the insulation there at the bottom of the pads. And so I want these ones at the bottom of these pads, which leads me to about right there, if that makes sense. And yeah, hang on a sec here. Let me make sure I measured that right. Bottom of the insulation. So yeah, so if we're putting that much on, I want the same amount on these other ones. Sorry guys, I haven't done this for a while. I have to actually think about this for a sec. It's easy to make a mistake when you're doing a video. Yeah, so right there we need that. Okay, we'll strip those quickly. 1/4 inch. Next, what we're gonna do is we're gonna tin all these wires just like we tinned this side. Again, you can use flux on this. It doesn't really matter. Sometimes I do, sometimes I don't. It just depends. Because most of this is all silicone wire, it doesn't burn the insulation too badly, so you don't always have to do this with flux for these little wires, but flux is always a good idea. Getting tangled up here. All right, need our solder. And this, I usually use my helping hand that's over there, but for the video I'm not going to. I'll just do like this. So, clean tip. Add your solder. And these don't have to be done super well because they're also going to get coated in solder when you do the rest, when you attach them. Okay, good to go. Those are all done. Just double check. You've got every other one that shortens. So long, short, long, short, long, short, long. Perfect. Okay, so at this point, if you haven't done this before, maybe just double check to make sure that you know that this is your positive and that's your negative, which I know it is on this in this video here. Okay, next what we're going to do, we're going to strip the main leads. So 12 gauge wire, 12 gauge setting is there. And again, make these, I like to make these just over 1/4 inch. And I'm trying not to cut some of the wire inside, because I found that these actually are a little bigger than 12 gauge, but it's good enough. Okay, this is nice pliable silicone wire. That's what you guys want, by the way. Don't get any of that hard, you know, wire that has the stiff insulation. That stuff's just a pain in the butt. Now for this thick 12 gauge wire, or bigger wire even, or even smaller, but make sure you put lots of flux on here because it's hard to get this stuff hot. You really want to transfer the heat in there. Clean your tip. And I like to just twist it with my other hand. See how it's coated like that? See how shiny it is? It's exactly what you want. Set it aside. Okay, see how shiny it is? Perfect. Okay, so that's filled with solder. Now, let's put our main leads on. I like to do the main leads first just because they're the important ones, and just find it easier because you need to use a lot of heat to really get that, you know, nice and pooled properly. So let's clean our tip again. All right, make sure we're lined up in the video here. Yeah. Okay, so get some on there. I want to put the insulation just above the pad. So put lots on there to really transfer the heat. Get the wire hot first. Get the base hot. And then put some heat on the wire. Make sure it's really pooling a lot and then let go. Perfect. So guys, you know a solder joint is really good. I clean off in between these big ones because these are so important for current. I can't remember what I was just saying. That hot first, the pad, and both of them. Yeah, oh yeah, that's what I was going to mention, or what I was saying is, see how shiny all of these are? If you ever are looking at a PCB or any type of electronic soldering, and you're wondering if the joint is good, if it's a really dull looking color, like this stuff I flicked off of the, look at how dull it is in comparison to that. See the difference? That a lot of times means that there could be a cold solder joint there, a weak solder joint, and it can break, possibly in the worst case scenario, but it also can be super high resistance. And if it is, that could be, I mean, depending what you're doing, what your application is, but that could be your bottleneck, especially on battery. Like if these leads were poorly soldered, that would not be good, because then basically it would be heating up in flight, and you have the potential to actually burn the lead right off. It's kind of like the equivalent of using way too small of a connector in a hydro application. Like if you were to use a JST connector, a red JST connector, when you should have been using an XT60, for example, the thing's just going to melt. So I've seen guys that I fly with have it happen. Okay, so what I like to do here, guys, first is I like to do the small ones. I just want to double check my lengths. Yeah, they're okay. I just like to do my short ones here first, get them out of the way. So clean the tip, solder on the end. Make sure you guys can see this okay. All right. Just do one at a time. Like I said, get the whole pad nice and liquefied. Hold it very still till it dries. Hardens, I guess. You can see how the solder really transfers heat. So I'm really getting the pad liquefied, because you really want to get a hot joint, because these batteries are big heat sinks, so they really dissipate a lot of heat. So just be mindful of that. You don't want to have a cold solder joint. So okay, we'll do these ones. Just clean this tip off again. All right. Now guys, if I was building this pack to be like, for example, one of my drone racing packs, you know, that's under a lot of crash stress potentially, I'd really want to make sure here that I take a few extra precautions. Like really, I mean, these are very solid joints. They're, you know, 1/4 inch soldered in their nice big pool of solder. So I would be totally fine using this in any application like that. But I'm just saying, if you're using it for potentially a crash ridden scenario, then make sure you've got some extra protection in there to not rip things out. Okay guys, so this part here, generally when I do this, I do it together with these leads at the beginning, but for the sake of the video, it's just too hard to show that. So, and it's kind of a pain in the butt to try and do it all in one. So I'm doing it separately here. So what I'm going to have to do is just give this wire a bit of a bend to reach. And so what I'm going to do is actually hold both wires here. Okay, so just gonna double check my tip is nice and clean. Get lots of solder on it. It's hiding behind here. Like I said, usually I use my helping hand, but it's okay for this video. And I don't want to just do that. And why is that, guys? It's because that potentially heated up the whole pad too much, but yet not enough. So it might have heated the whole pad up a bit and caused basically a weak cold solder joint, and I don't want that, right? So you want to make sure you get that whole pad liquefied. Hot on the fingers. Okay, see how shiny it is? Perfect. That's what we're looking for. And like I said, lots of heat helps. Lots of heat. I used to use those Weller handheld guns, and they're okay. But for doing things like batteries and some of the the big stuff where there's a lot of heat dissipation from the heat sink or whatever you're doing, they just don't cut it, I find. Even the big ones. they're okay. Like, don't get me wrong, but these soldering stations, like, you just program in, this is a pain, program in your temperature, and man, it makes it awesome. So be careful you don't bridge that there, guys, when you do this one. I love when people do it though, and how it scares them, because it makes a huge spark. Okay, so again, whole pad, get the whole pad liquefied. See it all lift. Okay, hang on here. I'm gonna do that a little bit better. Okay, perfect. See how shiny it is? Now, double check your order. In fact, I'm going to show you guys something just to be extra safe, because I said this is going to be a safe video. Okay, so what I would do, if you haven't done this before, even if you have, this is a very good idea, because you could save burning out all your stuff. Turn it on to your DC, and this might seem really stupid to you guys. Why is he testing the positive and the negative? How stupid is that? But look, this is the reason I'm doing it. I'll put this up so you guys can see it. This is why I'm doing it. Because if that number does not read positive, and it is, so that means I got them the right way. If that number read negative, it means I reverse positive and negative, and you're going to short out all your stuff or cause a big fire when you plug that in. So that's a good thing to check. And actually, while we're here, let's check our balance taps. Something you can do is to make sure that you got this together like we just checked. You're obviously going to have your total voltage. Sorry, guys. I'll reverse my lead so I'm all in positive for you guys here. Hopefully you can see that. Okay, so positive, and then we can go cell by cell. So you can go here, and each one's going to be around your storage voltage. Here, next, next. Yeah, they're all showing 3.8. Be careful you don't short a pad out when you're doing this. Okay, these packs have been sitting around for a long time, so they're a little bit off from storage, but that's okay. Okay, next, so we're going to take our heat shrink. I've already cut it to 1.25 inches, just a length I prefer. And actually, before I do that, I like to give this wire a bit of a wiggle. Sometimes the solder and the flux get in there, make it a little bit stiff. I'll just stick these on. And why I put these on here is, again, protection, safety, because those wires really get tugged on, especially in a crash, and it's always in this place where it's going to get frayed or cut, usually if it's not physical prop cut or something like that. So you want to put something on there to reinforce it. So heat shrink's awesome. So I'm just going to grab my gun, plug this in. I'm going to apologize for the noise ahead of time here, guys. You can use a lighter to do this too. All right, good to go. Okay, now that those are on, let's see, next, I guess we'll start insulating this again. Take your insulators that fell out and slide them back in. Now, what these are for is just to keep, so that if these were to hit in a crash or mishandled or whatever, then it's going to keep them from shorting out. So you can put them in. And actually, these packs aren't too bad. I've taken apart some packs that are kind of, I don't want to say horribly done, but definitely not very safe, like insulating wise. You can see here, this is a little tight. Like, there's potential for an issue. So you know what? I'll show you this right now. What I like to do is, and I'm actually going to demonstrate this, liquid electrical tape. Awesome stuff, like I said earlier. I'm going to use this. Give it a shake. I haven't used this stuff for a little while. And it's pretty messy. It reminds me of applying PVC glue, if you've ever done that, the two-part stuff. It's really messy. And And you know what? Why don't I do this for the sake of this video? I'll do it all properly. I was going to use electrical tape to insulate each one of those terminals, but why don't we just do this? So take your messy liquid electrical tape and just brush it on. And yeah, it'll make a mess, but don't worry, this is all going to be covered up. And this way, this will insulate it all, and you're never going to have to worry about, oh, did I do a good enough job? Or, oh, what if somebody drops it? Is it still safe? Yeah, it should be fine because you've spent your time insulating it properly. See how messy this stuff is. Now, if I was doing this on my own, I'd probably do a little bit nicer job, but I'm trying to rush a bit for this video. Make sure all those pads you can see are covered. At least the majority of them are. Okay, good to go. So guys, if you don't have liquid electrical tape, just take some regular electrical tape. And you actually just rip off a piece and put it over. Splay it right over each piece. And if you don't have, well, everybody should have electrical tape. But if you have an issue there, like I did there, where it was kind of close, you can just take anything that's insulating. Take a piece of rubber. Take a piece of, I don't know, anything. It doesn't really matter. Anything that's insulating, anything non-conductive, and stick it in between there. Just make it up. Even like you could use a piece of plastic or Teflon board or carbon fiber. It doesn't really matter. Anything that isn't, no, don't use carbon fiber. Actually, I take that back. I was thinking light in my mind. Carbon fiber is very conductive if it's the real stuff, so don't do that. But anything that is non-conductive. Okay, guys, after this, I'm going to let this dry for the sake of the video. I'm going to turn it off here, but I'm just going to prepare this thing, get rid of this old tape on here and get it ready to go. Okay guys, for the sake of the video, I'm going to make a bit of a mess here because I just want to show you guys something while this is drying or before it dries. If you guys didn't have the liquid electrical tape like I was talking about, one thing I want to do to show you for safety is what you do is you pick up all these leads. Now normally yours won't be covered in electrical tape, but lift up all the top ones like this. I'm just going to break all of these. Okay, and so what you do is you take a piece of electrical tape, slide it in there, and you want to actually get underneath those and over top of the bottom pads. Just like that. And I actually like to do two sometimes. And the reason for this is that over time, if this was a heavily abused lipo, like in a racing drone application, for example, I know I like to crash quite often, it seems like. Getting this all over me. Where what can happen is these balance leads, these upper ones, can wear through on the metal sharp pads on the bottom, and that can cause a short, right? So this way they're totally, not only were they insulated from the liquid electrical tape, this is kind of overboard, but I just wanted to show you this way in case you didn't have the liquid electrical tape. But by doing it this way, like when the liquid electrical tape dries, it's not going to let the wires move, so you don't have to worry about that. But because it's just a solid mass, I mean, you could even use hot glue if you really wanted to. But in the sake of, or for the sake of safety in this video, I'm just showing you how you can use electrical tape to just pad those metal pads, and then that way you won't have something wear through. And while we're at it here, I'm going to do just one more piece on the top of it, just so that everything's insulated properly. Like I said, this is kind of overkill, but why not? It's lipos. They're dangerous if they're not handled properly. They're never dangerous if they're handled properly, and they're usually pretty good, but it's usually mischarging, misuse, damage, you know, lots of reasons like that. Okay, so take all your wires and just kind of squeeze them together a little bit. And make sure you got all your insulating pads in there, which I do. Take your original piece we ripped off. I took the tape off of it. And we're just going to set it on there right in the middle. And before you stick the sides, I like to really push on it. Lift the sides, stick them down. And by pushing on it like that, you just get everything nice and solid. Okay, perfect. Now sometimes when you push on it a little bit, you'll find this, see this makes a bit of a ridge here. So sometimes what I do is I just lift this, just take a pair of scissors and just cut off the excess here. You don't need a lot, but maybe 1/8 of an inch. Here I'm in Canada using imperial, or using standard, and sometimes metric, all over the place, but most of you guys out there will understand that. Okay, once you're done that, done with the electric tape, take your either packing tape or fiberglass reinforced tape or some sort of really good quality tape, and just center it on there and pull and stick. Same thing. Perfect. All right, guys, so that's just dirt from the, or I don't know, something from on the bench anyways. It's kind of a mess doing this so quickly, but you can see I overlapped it a little ways just so it will never pull off. Lots of reinforcement there. It's really solid. These wires are nice and solid in there now. They're not going to come out. There's, like I said, we've soldered on 1/4 inch on the tabs, so they're really in there. These are all protected now. These are going to bend forward with the heat shrink. So everything's looking really good. Just inspect the pack while you're at it. And like I said, this is I was doing this as a repairing or replacing leads, but I mean, maybe you want to change the cell count. I've taken Lipos apart. Just be very careful with the pads, and you don't want to cut them too short, the tabs, otherwise you can't use them again. But you could maybe take out a dead cell, or make a bigger pack out of 2 smaller ones if they're the same MAH. Yeah, I don't know. There's lots of different things you could do. Be careful when you're taking 2 different packs and putting them together, though, because if you don't know about what IR is and different things like life cycle and capacity and all that kind of thing, then you can have some issues. I usually only do it with packs that have been matched or been used in the same application, that are the same brand, same size and everything. But anyways, we're good to go there. Last thing I'm just going to show you is the heat shrink here. So I've already cut off a big piece of heat shrink. I won't waste time showing you that. I'm just going to wipe it off here because it's dirty from on the bench. So we're just going to take our heat shrink and slide it over the battery. Now this is really thick, heavy duty stuff. You don't have to use something this heavy duty, but this is, I'm not using this. This is going to be for a charging pack, like I said, so it doesn't matter. Just slide it in there. These all want to come forward. And you want to overlap, I don't know if you can tell there, you want to overlap about 1/4 inch or a little more on each end. It's probably more like 3/8, or for even 5, well, no, probably about 10 millimeters, I'd say, if you're into the metric thing. That looks pretty good. Center it, and then we'll just apply our heat. Okay, take your gun, apply our heat. It gets really hot here, so it's kind of a pain to do, to be honest. So I usually start just with one side. And I'm using high heat here. This is really, really thick heat shrink though. Most of you guys won't have heat shrink like this. I bought this specialty just for packs that, are going to take a lot of abuse. It's good heat shrink. Or packs that maybe you're not going to use in flight, like, because it's a bit heavier heat shrink. Like I said, because these are charging batteries, so they're going to be used to power chargers. I don't mind a little extra weight, obviously. You can see it shrinking up there. And then I usually like to just make sure everything's good, clean it off. And just get the ends a little bit more. You don't want to get the lipo too hot, so just be mindful of that. At the front. I usually just pull these down a little bit. And notice that I haven't stripped the ends because you don't want to short out those main leads. That'll make a real big spark if you do that. So don't do that. When you're putting on the battery connector, do one at a time as well. Don't strip both of them, because you'll accidentally at some point in time, you'll accidentally short them together, and that's not good, especially if it's a really good pack. And there we have it. Finished, complete lipo. All done. Nice leads, everything's well protected. I'm gonna let this cool off a little bit here first, but yeah, we've got our new balance tap on there, our new leads. I'll obviously put my XT60 on, but I'm gonna save that. I don't need to show you guys that. You guys all know how to do that, I'm sure. And I'm bleeding because I must have cut myself with my, I don't know what it was. Anyways, but we have the completed pack. And I don't think there's anything else to tell you guys. If you have any questions or comments, put them in the bottom of the video here in the space provided. Otherwise, give me a thumbs up, maybe a subscription if you want to see other cool videos or how-to videos like this. I do lots of reviews, lots of random stuff, so check it out. Thanks for watching on how to build, or rebuild, I should say, a lithium polymer battery the safe way. Thanks for watching, guys. I appreciate it.